Hello everyone, it's Wilson here. Today let's talk about finding the tangent line to the given space curve with the parametric equations and then at this point. Okay, so how do we start the problem? To start the problem, first we can just do like a really rough sketch. Maybe it's not going to be accurate, but it doesn't matter. We just want to know the idea, so we can actually just sketch it at this point. So maybe the curve is going to look like that. Okay, and then so what really happens is that let's say if the point 0, 1, 1 is actually at this spot over here. So this is the point 0, 1, 1. Our goal here is to find the tangent line. So the tangent line is going to be this one over here. So that is the line that we are trying to find. Okay, now we just reviewed that when it comes to finding a line in the space, we need two things. Okay, so we are going to need two things. Let's just write it down. Need two things. And then so what do we need? So one is that we are going to need the point. And so we need the point. And when we are writing that down, then we are going to write it as a vector, as the position vector pointing to that point. So in that case, we are going to need the R0. So we need that. And then you may say, do we have that? Do we have that? The answer is yes. As you can see that we already are given a point, right? So we already have the point. We have the 0, 1, 1 over here. This is more like scratch work, so it doesn't matter how you are formatting it, right? Because we are going to do the formal work in a minute. So now the next thing that we need to have is the what? Is the direction for the line. Okay, so we need the direction for the line. And that one is our V for this. Okay. Okay, so in this case, so we need the V, and that is the direction vector, and then you can see that this is the V, and that direction will be parallel to our tangent line. So we need that. And do we have that? At this point, we actually don't. Okay, now how do we find that? We know that the line is going to be tangent to the curve. So now we need the tangent vector to this curve at this point. And then so you may say, how do we do it? Well, let's get started. Well, first we are going to write the parametric equations, okay, in the form of a vector function. So we can actually let that be u is equal to, okay, so you can see that the x is equal to this expression here. So e to the negative t and then sine of t. And then do the same thing for the y and the z. Okay, so now we have the vector function that is representing this curve. Okay, and then our goal is to find the tangent vector. The tangent vector is to take the derivative for our vector function for the curve. So we take the derivative, so we get the u prime, okay? And then what do we get here? We take the derivative now with respect to t, and what really happens is that we are going to have a product here, so we're going to use the product rule for the differentiation. So first we are going to differentiate e to the negative t, which will give us what? Negative e to the negative t, and then the sine function, we just leave it, okay? And then now the second one is that we are going to add, and then now we keep the first function, so we are going to just copy it and then differentiate the second function. So we get cosine t. Okay, so that is our first component corresponding to this one, and that is the derivative for this expression here. So this is x prime, okay? And then what about the y prime? So we take the derivative for this thing, so we use the same idea here. We gotta do the product rule. So we have negative e to the negative t, and then copy the second function. And then now take the derivative of the second function, which will give us negative sine. So we get negative e to the negative t and then sine of t. And you see that I'm just copying the first function now. Okay. And then lastly, take the derivative for this function. So we are going to get negative e to the negative t. Okay, so that is our u prime. Okay, this is the what? This is the tangent vector. This is the tangent vector. And then, of course, this is actually based on t. So if we don't specify a t value, then we will not get the tangent vector at that point. So we need to find the t that will correspond to this point. And so right now, what really happens is that we need to think about what t value that we plug into those x, y, z will give us this point. So let's write it down first. Let's write down the parametric equations. So let's put this aside for now because we don't have the t value. So now we want to find the point. Okay, so next we need to find the t value. So here we find the t that corresponds to the what? The point 0, 1, 1. Okay, and so that means what are we going to do right now? So let's write down the parametric equation. So we have x is equal to, what is that, e to the negative t and then sine of t. And then y is equal to e to the negative t and then cosine of t, and then z is equal to e to the negative t. And so you can see that the points would have what? X, y, and z. Okay, so now if you set each one equal to the corresponding values, then we are going to get this. Okay, so we get this. And what really happens is that if you just look at this equation over here, when you plug in 0 for the t here, sine of 0 is 0, so 0 looks like it's going to satisfy this equation, right? But also you can plug in the pi, you can plug in the 2 pi, you can plug in the 3 pi, and then it will still satisfy this equation. The problem is that when you plug that, let's say the pi into this equation, then you are not going to satisfy this equation, okay? Same thing for here. So even though the first equation has more than one solution, but we need to look at which equation will actually help us figure out the t value that we want. And the easiest one, as you can see, is the third equation over here. So we should actually look at this equation and see what's going on. Okay, so this equation, if you simplify it, it's going to be what? This has negative exponents, so we can actually write it as 1 over e to the t. And that is equal to 1, okay? So we can multiply this e to the t to this side, okay? Then we are going to get what? We are going to get 1 is equal to e to the t. And so now that is actually a really easy equation for us to solve, right? You just need to ask yourself what t value that we plug in here will just make this true. And or you can change it to a logarithmic form. Then either way, you are going to figure out the t value that is really easy. It's t equals 0 because e to the 0 is equal to 1. Okay, so t equals 0. Now we need to plug this back into the first equation and second equation. Just do a quick check and make sure that t equals 0 will satisfy both equations. And right now we plug the 0 in here. This e to the negative t is not going to be 0. So if we, and it's actually in the denominator when you change that exponent to just t, okay? So if you plug the 0 in here, you're going to get 0. So that will satisfy the first equation. What about the second one? You plug the 0 into the cosine. Then cosine of 0 is 1, okay? Plug the 0 in here, it's also 1, so 1 times 1 will give us 1. So this is actually a t value that will work, okay? And then now you may say, what's next? Well, the next step is that we are going to use this t value, plug that into our derivative function, the tangent vector, okay? And then we can get the tangent vector that is parallel to our tangent line. Okay, so we are going to now look at this. So I'm going to write this one as u prime of t, okay? And then because it's a function of t, right? Actually, I'm going to plug in the t equals 0 over here. So this is t equals 0 because that corresponds to the point. And so what happens is that we plug in the 0 into those expressions. You see that we plug in the 0 over here, we are going to get 1. Okay, so we get negative and then 1, and then what is that? 0, so we just get 0. Okay, so we get 0, and then plus, and then we plug in the 0 here, we get 1, plug in the 0 here, we get 1, so we're going to get 1. What about the next one? The next one has a cosine, so that's 1. This is also 1, so we just get negative 1, and then minus. Plug in the 1 for the sine, we get 0, so we just get 0 here. And then next, we plug in the 0 for this t over here, we just get negative 1 because of the negative sign in the front, so we get negative 1. So simplifying that, we are going to get what? 1, negative 1, negative 1. Okay, so this is the tangent vector that we want. Okay, so this is our tangent vector, which is also the direction for the line that we're trying to find. Okay, so that can be used as the direction for the line, the direction vector for the line. And so now what are we going to do is that we are going to actually just write it out. So this is the tangent line that we want. And then we can write it as r of t is equal to r naught plus t times v, okay? And then we just need to fill in the r naught and the v. And so what is r naught? Is the we already have that over here, which is our point, right? 0, 1, 1. But remember that we are going to write it as a position vector. So we are going to get 0, 1, 1. So you can see that I'm writing it as a vector. I'm not using the parentheses over here. Okay, so now plus, and then t is the perimeter, so just leave it. And then v is the what? V is our direction that we were trying to find, right? And so what really happens is that we are going to use this one as the direction. So we are going to have 1, negative 1, negative 1. And then now simplify this, we are going to get what? We are going to get 0 plus t times 1, so we just get t, okay? And then 1 plus negative t, so 1 minus t. 1 plus negative t as well, so 1 minus t. And so this is the vector function for our tangent line, okay? So we have that tangent line equation. But this is the vector equation. We are finding the parametric equation. That's what the instruction is saying, right? So we just need to write this in the parametric form, but that will be really easy because the first component is the x, the second one is the y, the last component is the z. So we can actually write it in the parametric form. So it's going to be what? X is equal to t, okay? And then y is equal to 1 minus t. And then z is equal to what? 1 minus t as well. And so we're finished with this problem. Okay, so hope you like this video. Please subscribe and share this video with others. Thank you for watching. I will see you next time.